Well, hello and welcome, everyone. My name is Steve Stedman, and I'd like to welcome you to this training on analyzing TempDB with Database Health Monitor, which is a program that we've created at Stedman Solutions. To jump into it, to get started, a little bit of background. We've got a few of our team members on the call. We've got myself. I'm the founder and owner of Stedman Solutions, which we're just about hitting our 9th anniversary of being in business doing SQL Server consulting and training. We have Shannon Lindsay. Shannon is my executive assistant, and she will be helping out during the call. We have Laura Tullett. Laura is a developer and one of our managed services, DBA and leads. So during the call, a few housekeeping notes up front. While we're streaming, I'm not able to see the chat window or the attendance on Zoom, so Shannon will be monitoring that. And we'll have plenty of time at the end for any questions that come up. Please hold the questions to the end. Once we get to the end of it, we'll go through and answer all those questions. And then we'll also have a freebie available if you stick around to the very end. So don't miss out on that. All right, so to jump into this, one of the first things I want to cover is what is TempDB? And with Microsoft SQL Server, you've got your system databases, your master, you've got your model, MSDB, and TempDB. TempDB is a little bit different from all of those other databases in that TempDB, it's temporary. It holds objects that are internal things that are being done when queries are being processed, and it also contains version store information. We'll get to that in just a minute. The difference with TempDB is that most of the objects, such as temporary tables, are automatically cleared up when they're no longer needed, typically at the end of the session or the transaction that created them. So that what that means is if you create a table variable or a temp table, those things get cleared up at the end of that session when that session gets closed, or when you drop them or clean them up yourself. TempDB is pretty essential for your performance optimization in that there is a lot going on when queries are being processed of what's being sent into TempDB, things related to sorting or grouping operations, complex queries that require something along the way to store the immediate results. A lot of the times you might have two tables that are being joined, and then that's being joined to something else, and those results of the first join might be stored in TempDB as that query is being processed. TempDB is a crucial part of SQL Server, and if it doesn't run well, you may have some issues along the way. As I mentioned, it's one of the system databases, and one of the things you want to keep in mind is that it's automatically created when SQL Server is installed, and then it's also recreated every time SQL Server is restarted. So let's say you put a bunch of stuff in TempDB, you fill it up with a bunch of tables or big queries, and somehow your SQL Server gets restarted or rebooted. Well, when it comes back up, that TempDB file is completely blanked out and started out fresh every time, ensuring that you've got a clean state. It's very different than how all your other databases behave, and it's ideal for temporary data storage. But it also means that nothing you put in data or in TempDB is persistent or is going to stay around typically beyond the end of your session. And there's some ways to get around that with like global temporary tables, but nothing will stay around beyond the next reboot of TempDB. So a little bit more info on TempDB and why this is important. There's only one TempDB per SQL Server instance. And what that means is whether you've got a small departmental SQL server that you've got 12 people using it, or you've got a big SQL server that has thousands and thousands or even tens of thousands of people using it to back some website or some system like that, you only get one TempDB database per SQL Server instance. But that TempDB should have multiple data files because that helps spread out the load. And oftentimes you want to have those TempDB data files on your fastest or almost fastest storage that you have available. And the reason is because there's so much work going on in TempDB there that could be bogging down queries if it's going to be slow. TempDB can become the bottleneck on a busy system. Now, take for an example, and it's kind of small print down at the bottom there, so I'll just read it out. But one database I worked on, or one SQL server I worked on recently, had 1,500 databases on it. And of course, because a single SQL Server instance, it only had one TempDB. But what's happening is queries from all of those 1,500 databases share TempDB. Now, those 1,500 databases weren't that big, so the databases alone didn't overload the entire SQL server, but we found some big surprises in TempDB on how much load was being put on by those 1,500 databases all on being on one SQL server and sharing that same TempDB for that query processing. So another thing that really uses TempDB is RCSI, or Read Committed Snapshot Isolation Level. This is a change in an isolation level. I think it was introduced in SQL Server 2017 or 2016, but in my opinion, it wasn't quite stable back then. It's been available in 2019 and 2022, and we're using that with clients on both of those, and it's really amazing what it does. What it does is it makes it so that normally if you're selecting from a table and somebody's trying to update it, that select has to finish before the update can happen. Or two selects might be blocking on something that's waiting on an update. Well, what RCSI does, it makes it so it stores the changes of what's happening in your database in TempDB, thus putting more load on it, but it reduces the amount of blocking that's going on because you're able to read what that table looked like at the start of your query, even if someone else is updating it along the way. That's one of those things. It's a useful performance improvement. It works great in 2019 and 2022, and it's actually the default in SQL Server 2022. But what can happen because of that is on a heavy system with a lot of changes, you may get a pretty big load on TempDB. And TempDB is one of those things that it's kind of hard without the right tools to look at it and really say what's going on there. And we'll take a look at that in a minute. So let's take a look at some of the things that use TempDB. Now, there's what I consider kind of the more straightforward items. Temporary user objects. This includes tables, stored procedures, and table variables. That would be when you declare and create a temp table, or when you declare a table variable, or you have temporary stored procedures, things like that. Those all go into TempDB. They're explicitly created and they're designed to be temporary in nature, so they go in that TempDB database. Pretty common thing when you're doing processing of data, processing and queries, is you create a temp table, you throw a bunch of stuff into that temp table, and you work off of that. Well, all that work is going on in TempDB. Okay, some other things that use TempDB are internal objects. SQL Server uses TempDB for things like work tables, or for cursors, or for spool operations, or work files for hash joins or hash aggregates. If you ever look at your query plan and you see things like work table, or you turn on statistics.io and you see a work table referenced, really what that means is SQL Server, when it's processing that query, takes all the results it's got at that point of the process, stores them off somewhere in TempDB so that it can then use it in the next step. So there's a lot of stuff going on when you run queries there. And those are, I mean, if you create your own TempDB table, you probably know how many rows you're putting in there. May grow over time. But with these other things like work tables, if you're joining really big tables, it may not be obvious to you right off how big those work tables are or what actually is going on with TempDB there. And we're going to take a look at that, how to find those things in just a minute. Other things that use TempDB is the version store. And the version store is what keeps track of the state of your databases that are using read committed snapshot, or RCSI, that we talked about earlier, or snapshot isolation level, to keep track of the status of what rows looked like while they were being changed. Other features like online index rebuilds and things like triggers to store versioned rows, things like that, those will also be using up TempDB. Keeping in mind, you've only got one TempDB, even though you might have multiple data files, you've only got one of those on your entire SQL Server instance. Okay, other things. Query processing, group by, order by, and select distinct. Those are all things that require a sorting of a result set. And most likely, those are filling up, or not filling up, but those are using TempDB. If you have a subquery that's doing a group by, well, in order to do that group by, it has to sort everything in that result, and it uses TempDB for that. Select distinct also has to sort. Index rebuilds, specifically online index operations, use TempDB to store what's needed during the rebuild process. And I think what you're seeing here is that there's a lot of stuff that's using TempDB. So we go down the list here, other things like DBCC commands. DBCC check DB, DBCC check table, things like that. Use TempDB. I've seen where people will run DBCC check DB to check the database consistency. And if there's no TempDB space available, it fails because it can't create what it needs in TempDB in order to do that check. And the font gets even smaller here, and there's lots of other things that use TempDB. But the point here is there is a lot of stuff using TempDB. And some of these are features that might be optional. Some of them might be features that everybody uses, like group by or order by, but it's all taking up TempDB. And what happens is if TempDB is under load, all of these things that we describe here get slowed down. If you're running into issues where you don't have enough I/O to keep up with all the work that's being done, well, those things are going to slow down. And nobody likes slow queries, but it's not always obvious when you're looking at a query plan whether data that's spooling to TempDB is going to be slow or it's going to be fast. And that's what we're going to take a look at. How do we find those things? As we get into this, I want you to think about a couple of things. What do you use today when you're working with TempDB? Do you have any tools in place already that you can look and see what's happening with TempDB? I know I've got a lot of tools that I use for analyzing other databases, but TempDB, until recently, with some things we added to Database Health Monitor, it was hard to figure out what was going on with TempDB. And Laura Tullett, who is on the call, she is one of our developers who worked on adding a number of these new features into Database Health Monitor for analyzing TempDB. We'll take a look at some of these things that she added here in just a minute. Next question, how do you know what is adding load to TempDB? If you've got 100 people using your database and they're running queries all day long, every day, whether it's OLTP or reporting or analytics or whatever it may be, can you pin down specifically what your problem query is or what the biggest thing is using TempDB that's causing I/O issues or slowdowns or causing the files to grow, things like that? And how do you track down specific times that TempDB is under load? That's an interesting one because a lot of the times, and maybe the general question with that is, do you know, is your TempDB under load during the day or during your prime runtime where you're trying to get the most performance out of your server? Or is your TempDB under load the most during the night or your downtime when you're trying to do checkDB and backups and index rebuilding and things like that? Well, generally, those are kind of hard things to figure out with TempDB. So let's take a look at how we can analyze those. Okay, so here we have Database Health Monitor, which is an application that I started building about 12 years ago. And it's been a big part of the Stedman Solutions offering that we have. It's a product that we sell as a standalone product, but it's also something that we give away for all of our managed service customers. And those are the people who hire us to take care of their databases on a month-to-month basis. And what's happened with Database Health Monitor is every time we come across something that I look at it and I say, well, I can't figure out how to detect this in SQL Server. Well, I figure out a way to do it, and then we build it into Database Health Monitor. So there's a whole lot of stuff in Database Health Monitor that's designed specifically around how do we find something that wasn't really easy to find before, or that you might have had to have your bag of queries that you bring out in order to go and figure out what's going on. So what we're going to look at here, I have this test server. It's called MultiSQL, and I've got about 14 different SQL Server instances installed on it, every version from 2008 to 2022. For the purpose of the reporting we're looking at here, everything we're looking at works on SQL Server 2008 and newer. And we'll be specifically looking at SQL Server 2022. And what we've got in Database Health Monitor, the first thing we're going to start with is a chart on I/O by database. And there's these instance level reports kind of in the center of Database Health Monitor down here on the main page for each instance. And I'm going to click on I/O by database. And when you look at a server and you see that 98% of all of the I/O running on this server is going to TempDB, that's a bad sign. That's a bad sign in a lot of ways. Now, this is a test server, and I just have a test load running on it right now that's specifically being a little bit harsh on TempDB, but it's an indication that there may be something wrong here. Now, if you look at your production system and you've got some pretty busy databases with this, you might see And here I'm going to take a look at a different report here. This is a different instance. And this is an instance that hasn't really been used yet. So all it has on it is model, master, MSDB, and TempDB as the databases. But you can see with that TempDB is certainly not the biggest factor there. If we look at other ones, yeah, we can see MSDB, TempDB, and DB health history on this report. And as I'm just using the control up and down arrow to page through these different reports for the different instances here. But let's go back to this multi-SQL SQL 22 instance. And on here, 98.8%, we'll just round it to 99% of all of the I/O that's happening on all of the databases on the system is going to TempDB. Okay, so let's pause for a minute and think, if this was your database, this was your SQL server, and you saw this, what would you do? Where would you go? Where would you chase to try and find out what's actually using up that space on TempDB? Now, a year ago, my answer would have been different. A year ago, my answer would have been, well, I'm going to go look and see what queries are taking the longest and what have big temp tables and things like that. And maybe I'd run some queries to go and find that. But what we did is we went and built the monitoring for this and added it into Database Health Monitor. We're going to expand on the left tree view over here, this multi-SQL SQL 22. And before we go in to show you what's going on, I want to tell you a little bit of a story here. I have this database in here that's called boating locations. And one of my hobbies is boating. I have a boat, and my wife and I go up in the San Juan Islands and into Canada during the summer, and we do a lot of boating. So what I did is I built a database to track all the different places that we could stop and then to do route planning. So if I know I'm going to go 40 miles in the boat today, well, this is the route I'm going to go, and these are the places I'm going to stop. Well, then I started adding more and more stuff in there, and all of a sudden I've got like 500 different locations, and some of my queries started running slower. And that's what we're going to discover in a minute is what, and technically on this test database, the only thing that has any load on it right now is this boating locations database. However, you don't see that from the I/O. The I/O is all going on TempDB. So let's go down and we'll expand the TempDB in the tree view here and expand the historic section. And all historic means is that it's data that we recorded in Database Health Monitor as part of our monitoring that's not live right this minute. It's something that may have happened an hour ago or yesterday or even 5 minutes ago, but it's things that we're tracking over time that you can come back and take a look at tomorrow. So let's say 3 days ago, well, let's click on this I/O by hour for TempDB here. This is interesting. So if we look at this, we can see somebody may have been saying yesterday on 3/19, between 8 a.m. and noon, they may have seen some bad performance on this server because that's the time that had the most I/O on the TempDB database. Okay. And they might have said, well, we had some other problems around 6 p.m. because the I/O might have been maxed out at that point. And in here, the colors go from green to red, with red being the highest I/O point. And this is looking at a week of data where each of the columns is a day and each of the rows is an hour. And we can zoom this out. We can go back and look for more. There's 2 weeks worth of data, and there's 3 weeks worth of reporting. And I'm on kind of a small screen here, so it's messed up the numbers a little bit. But what we can see is that prior to about 3:10, there wasn't much happening on this database at all. And then around 3:10, something happened, and we started getting a lot more TempDB load on this system. Okay, well, that's interesting because what this has done is this has shown us, given each day, day by day, and I'm going to zoom back in so we can see a little bit more detail here, that we can see there have been some specific spikes. There's been some standard running, looks like it's kind of in that green to blue range, which is around about 4 to 10 megabits per second. Now, if we look at a different server, you might see patterns, like if you have CheckDB running or index rebuilding running every night at 2 a.m., you might see that there's a spike every night at 2 a.m. And those are the kind of things you may look at it and realize, well, yeah, 2 a.m., let's use as much of the disk as we can in order to be able to get those things done so that they don't impact the performance during the day. Depends what your availability and your down or your high usage times are, but you can use this to figure out, well, when can we schedule things, or when can we do things, or when is my disk being used the most for TempDB? Now, this report, the I/O by hour, we have this available for all of the databases. So if we went over and looked at something like boating locations, and also looked at IO by hour, we can see that there is a same report and there is maybe a similar trend, but the IO on this database is way lower than what we're seeing on TempDB. Okay, so now that's good because that tells us when we're having spikes or issues in TempDB. And here's where you might go and try and hunt down, is there a job running, or is what's going on at this point of the day that might be putting that load on your system? But then let's take another look at this. Let's go into the TempDB use by hour. Now, this report is specifically related to IO. This next one, the use by hour, is specifically related to big queries. And here, the chart goes from 1 to 10, with 1 being the lightest, well, actually 0 being the lightest load, and 10 being the heaviest load. And with the heat map with the color here, and we can see that, yeah, there was definitely a lot more load happening on Saturday, March 16th here than there was on Sunday, the 17th. That's because there's this query I wrote in this boating locations database that is a little bit of a TempDB hog, and it's been doing a lot of work here. But I only know that because I've stepped ahead and I've seen the charts here. But if you want to look and see, okay, well, what's actually happening at that point in time? Let's just take a look right here at the column where we're showing 316, and we'll click on one of these 9 or 10s down here, which is the biggest load. And when we click on that, that takes us to a different report. And in this report, we can see that the biggest TempDB usage is one single query that happens to be session ID 83, which I've had running for overnight on my other computer connecting to this. And it's currently using 238 gigabytes of TempDB. Now, some people don't even have a TempDB database that's 238 gigabytes, but because we were creating the reports, I used this bad query that I wrote as a way to show something that really stands out in TempDB here. And I thought, well, I'll just keep adding space to TempDB and see how big it'll get. And this thing grows up to overall about 300 gigabytes in size before it finishes running. Now, when you look at this, you might say, well, how do I tell what query this is? I can only see the first part of it over here. And what I can do is I can double click on that, zoom in and see, here is what the query looks like. It's a CTE, or Common Table Expressions query. It's a recursive CTE for that matter, where it's selecting some locations out of a temp table. It's doing a union all to do a recursive call. And it's doing that and going really deep. So what it's doing is it's taking all the locations I've got in the database for boating, and it's figuring out how to go from point A to point B to point C to figure out all the different possible routes. Now, since I originally wrote this, because this works really small on a small database, I've rewritten this query to work faster without the CTE. But in this specific example, I kept it around to help point out the problem here. So what we're able to do is look at, we'll go back to the previous report here, the TempDB usage by hour. We can look at any hour of the day or the week. And if somebody says that TempDB was slow at that point, we can click on this and say, okay, well, yeah, this is why it was slow, because there's this really horrible query here. And we can look and say, Steve18, that's the name of my desktop. The user on that computer is the one causing all the problem with that. Maybe you should go talk to that person about how to write better queries. Or maybe we need to go look at how do we optimize something, or how do we fix something. And this is a really cool feature. So far, it's been about a month and a half to 2 months since we introduced this feature, and we've already used it. We've already used it with several of our ongoing clients to be able to find insight to show them problem queries that we didn't know about and that they didn't know about prior to adding these reports. It's been incredibly valuable. When you're working with a client that has a 70 gigabyte TempDB and thinks that's plenty, but they have one query that's taking up 65 gigabytes at any point in time, well, that's an indication that maybe their 70 gigabyte TempDB is not big enough, or maybe that one query that's chewing up most of that TempDB needs to be optimized or rewritten, like I did on this one, even though I keep it running around for the TempDB demo purposes. Then there's this last report under historic here, TempDB high usage. And what this one is, this is the same thing we see when we drill down on a specific hour, but this is for all time since I turned on this reporting. And it's sorted in here by what are the biggest things using TempDB at that point. If we sorted we can see that, yeah, the smallest is 136 gig, and it's just showing us the top several hundred and of the biggest TempDB hogs at this point. So when we look at the query, we can scroll down and see that every one of these offenders right here in TempDB is this same query. So if we were to go and find this query, figure out how do we performance tune it, figure out how to make that run without slamming TempDB so much, we might be able to improve the overall performance of this SQL server based on that one single query. Now, usually when I've looked at TempDB in the couple of months that we've had these reports on some pretty heavily loaded systems, usually what we see is that there's not one query, but there's two or three queries out of thousands of queries that run in the system that stand out as these are some of the biggest problem areas. So that's the kind of the demo on the reports of what we can get with Database Health Monitor. And Laura Tullett is the developer who worked on adding those into Database Health Monitor. She's on the call. Let's take a look at a little bit more information here. What I'm going to do is go to Microsoft SQL Server Management Studio. With this, we're going to open up Management Studio to the same SQL Server that we were just looking at, the SQL 2022 instance. We're going to go to the DB Health History database, which is where Database Health Monitor tracks all of its historic data. We're going into the table section and scroll down to two tables, the TempDB allocation table and the TempDB usage table. And what I want to do is take a look at what's in there, because if you go and select from these tables, we can get a little bit more information than what we have in the reports. And we can also, which we will be adding more information to the reports over time. And I'm just going to do this one order by ID descending. And when we run that, we can see that currently, right now, and this was actually about 1 minute ago when it logged this, 109 megabytes free in TempDB currently. What's using it is very little is using the version store, and internal objects, in that case, there's 59 gigs. There's 764 megabytes of user objects, and that internal objects are things that are used as part of your query. And when we scroll down here, we can see that this just keeps increasing. Well, as I scroll backwards, decreasing, because we've just got this really bad long-running query there. If we go take a look at the TempDB usage table, and I'm just going to select the top rows out of there, and then I'm going to change the order to see the most recent ones. This is very similar to the report that we saw when we drilled down on the hour or the what's using TempDB. We can see that there's one query. If we scroll over here, it's this recursive CTE. We can see that with that, it's currently chewing up 59 gigs, and that's been increasing over time. And the way we know it's increasing over time is it's the same session ID listed here about every 2 to 3 minutes that it's tracking, and it keeps getting larger and larger and larger, which tells me it's the same thing running. And we can see that TempDB currently, here's the free space as this runs, how much is being used by internal objects, and how much is being used by user objects. And if you want to find out the entire size of TempDB, you just kind of have to add up the size of the four of these to get the size of TempDB at that point in time. So additional information beyond the reports there that we can take a look at to learn a little bit more about the history and what's going on with your TempDB usage queries. And there's two tables that track this TempDB allocation and TempDB usage. In order for these to exist and to be filled in with TempDB information, we need to have the Database Health Monitor historic monitoring turned on, which is just one of the standard features in Database Health Monitor. Okay, let me go back to the slide deck now. Any questions at this point? Maybe Laura, I'm going to put you on the spot. You don't have to answer if you don't want to, but is there anything in the TempDB reports that I've shared here or that I haven't shared that you thought I might have overlooked or would be worth adding? And if your answer is no, that's okay too.
Hello. No, I think you touched on everything. We will be adding the to be able to see on that report. I'd like to be, instead of being able to or needing to do a query to be able to find out how much free space, we'd like to add that
Yep.
into the report.
Oh yeah, that's a good point. So one of the things we're going to add into the report that shows the exact queries was how big TempDB was with all the files at that point in time.
That's correct.
And,
Yeah.
and although we log it in the database, we don't display it in the report. And as soon as we started using that report, we discovered, gee, this would be really nice to have. So we will be adding that sometime in the near future. Yeah. Thanks, Laura. Good point. All right. Well, if there's no other questions at this point, we'll wrap it up. And I'd just like to say, everybody, have a great day.